Hey everybody, so in today's video I'm going to be going over the HackTheBox Medium Web Challenge WS-Todo. It was retired yesterday, so I thought I'd make a video on it. If you're watching this, I figure you're probably here for like educational purposes, or I don't know, maybe entertainment. Maybe you like listening to me ramble. I don't know, but I figured either maybe you're working on this challenge and you got stuck, or you did it but you want to see how someone else did it, or you never even tried it because you thought maybe it was too hard, but you still want to like learn how you could have done it or what you should have done. So I'm just gonna kind of approach the video from the aspect of like going over the challenge and pointing out like the things that I noticed that helped me solve it, maybe what I got stuck with, just kind of like a general going over of it. So if we look at the challenge description, it says this WebSocket-based to-do application features military-grade encryption and is extremely low latency, ideal for busy students and working professionals alike. So if you're not familiar with WebSockets, so like HTTP was designed as a stateless protocol, like it works in a request response fashion, right? Every request is sort of like the safe self-contained thing that has all the information the server needs to like respond to it. For every request, there's a response. So that's kind of like why like cookies eventually were introduced, because the web got more complicated and they kind of needed a way to have state. So, you didn't want stuff to disappear from your shopping cart. You wanted to be able to log in, like all those things like require some state. So that's where the cookie comes in, because then it allowed the server to have the back end like look up stuff and could include that information, whatever's relevant, in the response. Well, WebSockets is different, and that it actually negotiates a persistent connection. There's a handshake. It's what's called full duplex, where data can be sent back and forth simultaneously. So, in a lot of use cases, it's faster because it's like being on the telephone, right? Like you don't have to wait for the other person to respond before you can respond. Like you both can go back and forth. So that's kind of where they're talking about like extremely low latency. I think that's what they're trying to hype up. So if we look at the challenge itself, like what the application's doing. So I already, it has a register. You can register account. You can log in. I've already kind of done all that. And the application essentially just like has little to-dos, like you make yourself little notes. You can add them. Sadly, you can't delete them, but you do have fun little buttons to press. Gives you nice little inspirational quote for each of your to-dos that apparently it thinks you're not going to do. And yeah, so the way the application is designed is, all the like login and registering and all that stuff is handled with the HTTP request, where the adding and retrieving of all the tasks is done via WebSockets. If we look at Burp Suite, like this is the history of all the requests. So, I've already logged in and registered and done all that. And we can see that there's this endpoint here, this WS endpoint, which actually initializes. So we've already got an account. It passes along our session cookie, and then it's going to like switch to switching protocols. It's upgrading to a WebSocket. So we can look at the WebSocket history communication, and we see like the initial one. We're sending this is all just JSON, and we can see like here's where I told us add one. Here's the title, description. You can see it's going. There's no order. You can communicate simultaneously. If we get it back, we see here's it delivering my tasks, and we see it's all gobbledygook. That's because they've been encrypted, which is where I guess our military grade encryption comes in. And then the way it works is the application then, there's a secret. It's cached, so maybe the first time. So hit the secret endpoint. It gives you your secret, which is, each user has their own secret key. It's just randomly generated. And then you send to the decryption endpoint the IV, the content, and the secret. And then that decodes the message and displays it for you. So now that we have an idea of, what the application does, what it looks like, kind of the general big picture, let's jump into the code and start to try and figure out what it is we need to do to get the flag. So the first thing I always look at is a Docker file. This gives you the best big picture look at what's going on behind the scenes in the application. What's being installed, how's it being used. Here we can see we've got Node.js, MySQL Server, there's some PHP, and then a couple things to note in this particular challenge is we've got these 2 open ports here, which isn't typical. Like if you initialize the remote instance, you'd see you get back the IP and 2 ports. So going to look at what the other port is, like what else is going on with this application, we can see there's also this page here, this HTML tester, internal development tool, which if we look, we can see there's the to-do, and there's the tester. So if we look at what's going on with this tester thing that's running, we see it's just a single PHP file, where if we visit the page with an HTML parameter set, it'll echo whatever that parameter is into the page and render it. Otherwise, it just shows this little form, and then submitting it will do that same thing. So if we look, we can see, let's just give it some simple HTML. If I can type, we can see it puts it in this HTML parameter and renders it in the browser, renders it back. So right away we could think okay, this should be susceptible to cross-site scripting, which we can test if we just do a simple, which I probably spelled it wrong. It's hard to type with this stupid mic in my way. Script alert. Did I not spell it wrong? Oh. Hey, there we go. Where we can see, we've got XSS here. So right away we're thinking oh, sweet, we've already found a vulnerability. What's going on here? And then if you're familiar with a lot of these challenges, typically it's if there's an cross-site scripting vulnerability that needs to be exploited, that means there's some kind of usually right, because cross-site scripting is a vulnerability that takes place, client side. So we don't want to exploit ourselves. We want to exploit someone else. So usually in these kind of challenges, there is kind of a bot that goes out and simulates a user, visits the page, or updates something. So that's something to keep in mind as we're looking through the code, is to okay, see if we can find where that is taking place. The other thing we see, important thing we see in this Docker file, is we have these environment variables here, and one of them is the flag, which, right, the point of the challenge is to try and get the flag. So to do that, we need to know where the flag is. So it's good to know where it is. Is it an environment variable? Is it in the database? Is it a file in the hard drive? So here we know, okay, it's an environment variable. So where does that, does it come out anywhere? So one of the things initially I would do right away is I would grep for the flag, or just look through the code to try and find it. And if we do that, we will see in this WS handler JavaScript file, which handles the WebSocket communications, we see it comes out right here. So if we grep for flag, we would have got this line. We could open the file, come to it. So it looks like whoever has user ID 1, which typically always is going to be the admin, right? Because they're the first person in the database, that when they get their to-dos back, they get a quote, and in the quote they get the flag. So if we want to kind of verify, the next thing to do would be okay, how do we get user ID 1? Is there a way to get user ID 1? Who's user ID 1? If we look in the initial database, we see that when everything's set up for the challenge, the first thing, there's this insert. So it's inserting in the admin, his or her password, and their secret, which is that encryption key. So we know user one is going to be, or user with an ID of 1 is going to be the admin. So now we need to figure out, is that a way for us? Do we try and log in as the admin? What's going on? But if we think about, there was that XSS, it's probably going to be like, oh, the admin is probably, visiting the page over and over, and we're going to use that to exploit them into somehow giving us the flag. So with that in mind, as we go over the rest of the code, like you looking through the code to try and find where that's taking place, when we look at this index JavaScript file, which is in the routes, which handles all the HTTP endpoints you visit. So here's what it does when you log in, handling the registering. There's the secret endpoint, the decrypt endpoint. We see there's also a report endpoint, and they even give us a nice little note here. Report any suspicious activity of the admin. And so if there's a post request to the report endpoint, it does this do report handler, which we can see is a JavaScript file in the util folder. And we can open that up and read that code. And right away we see Puppeteer, which is that kind of handles the kind of like, I don't know, robot. It's like a headless browser that's like automated, I guess. So we can see what happens is when there's a post request to the endpoint, this login URL, which is the application, what they're going to do is they're going to visit the login page. They're going to put in their username and password, which remember those from the Docker, the environment variables, setting those up, and it's going to log in. And then after it logs in, it goes to the URL that was the input parameter to this function. So there is a way now for us to exploit the admin, right? The admin, whenever there's someone reports something, they get on and they go to whatever URL they were provided. Well, we have this other URL we can give them that if they go visit it, we can execute JavaScript code in their browser. So, and here's where it tells us it gets the URL from the request body. So like, sweet, like challenge over, right? Like the admin visits the page, they get triggered our JavaScript, and then boom, we get the flag. Well, there's some good news and some bad news. The good news is, first, I guess we need to talk about the same origin policy. So the same origin policy, it's a security mechanism where the browser restricts how a document or script located in a web page can interact with a resource from another origin. An origin being like, so origin takes into account the protocol, the domain, and the port. And if all three of those are the same, then it's considered the same origin. So essentially, you can change the path, but like nothing else. And so like way back in the day, they had to introduce this because like it was incredibly easy for, you go visit a web page and basically JavaScript can have you go off and, log into your email and do all these things and have access to all of it. So the way they combated that was to say like, okay, browsers, we're not going to let browser have access to information from a different origin. But that kind of screwed things up for a lot of developers, right? Because a lot of sites are like intertwined and they wanted to be able to get data from, their other, subdomain and all this stuff. So they kind of introduced what's called CORS, cross-origin resource sharing. So this is a way for a web server to send in the response header what origins should be allowed to access the data that's contained in the response. So like if you've seen the access control allow origin header, that's what it's doing. So if a website is going to make a cross origin request, there's a lot of, like you can just embed images. Like basically it's more for the JavaScript. Like, so if your JavaScript is trying to do something, that's involving cross origin, like depending on the type of request and, you know, different things, the browser is going to make what's called a pre-flight request, where it'll send like an options HTTP request, which is essentially like contacting the server and saying like, hey, I want to make this kind of request. Like, here's the headers I want to use. Actually the server will respond back like, okay, you're allowed to make these kind of requests with this kind of headers, and you can make the data available to these origins. So that's good news. Well, so that's bad news for us in that we can't just like access cross origin. Like our page, or the page when the admin goes and visits, is this has the 8080 port, and the script executes on that page, and it's going to the to-do application, or if we want it to go to the to application, it's on port 1337. So it's a different origin. So it's going to be a cross origin request. So we can't just access the data unless this server responded with the appropriate headers, which if we look at the responses, it does not. So that wouldn't seem to mean that like, okay, we can't do anything. We're stuck. Like if we look at like the response, right? There's no access control allow origins, or, you know, it's not making any, I guess we wouldn't have a pre-flight request, but anyway, like we can't do it. But the good news is the same origin policy does not apply to WebSockets. So we can actually have the admin, when it executes the scripts, use the WebSockets, and we don't have to worry about any of that. So sweet, we're back to like challenge easy, we're done, right? Well, if you're paying attention, you probably have figured out there's a couple problems with that, but we have enough kind of going on now that let's go ahead and like try and prove to ourselves that, you know, our hypothesis is correct, like that we can actually, you know, report a post, get the admin to like, you know, open it in the browser, kind of get everything going. Like the best way to tackle a lot of challenges is to like break it up into smaller steps. And so the kind of the first step would be like, let's just see if we can even get this to work. So we know that if we send a post request to the report endpoint, let me go ahead and this will just make a get, but it'll be in burp, and then that way I can. So here we have on the report, we're going to send it to the repeater, and we're going to change it to a post request. And we'll want to have content type. Oops. And we know that it needs to have a URL parameter in the body. And we're going to want to send it to they are on the server, so we can just send it to 127.0.0.1. Oh, it was port 8080, and it used the HTML parameter. So when we send this, it should, like, we don't know what happens, but we'll see whether or not if it failed, like, yeah, it just says okay. So we can assume the admin went and visited this page where nothing happened. We need a way to figure out if we can actually make that happen. So we could just, the initial thing we could do is just put in a fetch request to like a webhook that we control. We can actually just see, hey, does the admin even go out and hit that site? So let's actually just go ahead and do that. So script, we'll make a fetch request. Let's get a webhook site that we control so we can see if the admin actually visits it. We need to make it, is it mode or method? I think it's mode. We need to tell it this is a no cores response. Otherwise the browser will say like, hey, the script is being loaded in this origin and you want me to send your request to this site. That's cross origin. I'm not going to do it. So we have to tell JavaScript in the fetch request to be like, no, go ahead and do it, just to even allow it to do it. But then we can't actually see any of the data gets back because, again, we're dealing now with HTTP, so there's the same origin policy. We can't access that data, but we don't need to. We just want to see if the admin even just like hits the web page. And actually, I think I need to put that in. And I believe that's all I need to do. And then we can close off the script. So this is just very simple script that's just going to, when they load the page, it's going to make a request to our webhook site. Assuming I typed everything correctly and remembered the commands correctly, which is, sweet. So we can see here, and in fact, indeed, the admin, someone visited this page. So yay. So we know that our idea that the admin robot is actually going to these URLs is correct. So we want it to go to the WebSocket and get stuff from the WebSocket. So that might initially be like, ooh, what do we do? How do we get to interact with that? Because do we just make fetch requests? Like, how does it work? Well, if we remember, like, we interacted with the web page when we added, all these things in. We didn't look any different to us. So what was actually going on when that was happening? Well, we have access to that because remember, it's just JavaScript being run on the page. So if we go to that JavaScript that's running when we were adding it all, we can see what was actually kind of taking place. Here's the establishing the WebSocket connection. Here is this WS on open is what it does when it first opens up. We can see that action get that we had sent. This is what it's performing when it gets data back on every message. So we can just basically copy and paste a lot of this. So I'm going to open up a little note. So if we let's just copy and paste. So we're going to want to have it establish a connection. Well, first, right, we're executing this in our XSS. So we want to wrap it all in script tags. When it opens, we want it to send that get thingy so that we get the admin's to-do lists. When it comes back, we want it to do something. We're going to want to exfiltrate that data, which remember, and we don't need any of this because we don't need to do the same thing the application is doing. We want it to do something else, so we can get access to the data that's returned because remember, WebSockets doesn't have the same origin policy. So we can access that data and then exfiltrate it to our webhook server, where if this was coming from the HTTP, the admin's browser wouldn't let them wouldn't let them access that information. So we need to change this to one because they're going to themselves. And then when we do this, we will then do a fetch request where we'll go to our webhook server. And let's actually have it go to, I don't know if that's how you spell success or not, but whatever. We're going to post. So we'll do method post. Oops. We're going to tell it to do no CORS because we're making a cross origin request. We want it to tell the browser, hey, do it anyway, because it wouldn't otherwise. And then we need to add some headers. Let's see, we've got, be consistent. Application JSON. And then in the body, we want to send the message. data. And that's what we want. This is the script we want to have run when the admin visits that page. So let's just URL encode all that. Then we'll go back to burp. And instead of it sending this payload, we will send this payload. And hopefully, if I typed everything right, which is not a given. Okay, so we did. It worked how we expected, except this is what we got back, right? We see this was the data the admin got from their WebSocket, but we see there are no tasks. And if you remember, the reason we wanted the tasks was because in the code, that is where the flag came back, right? But if we look, it was included in the quote in their tasks. But if we look, this part of the code only gets executed if there are tasks, right? Here's the results, gets everything from the database, and then iterates over each one of them. But if there aren't any, this never gets run. So what we have to do is we have to have the admin add some to-dos, which again we can do because it's a WebSocket and we don't have to worry about the same origin, or that we don't have to worry about cross-site request forgery or anything like that. We just need to know how to send stuff. So we sent some stuff when we were creating our to-dos. So we just need to find in here where that takes place. And if we see, where is it? We see this WS send, and then it's JSON stringifying that data. So we can, again, our good old friend, copy and paste. So this time, when the WebSocket's first open, instead of sending our get, the first thing we'll do is we'll send this add that's telling it, hey, add. And we need to tell it to add a title. That is, we'll just say some title. And we need to have it add a description, which is just some description. Now, when this gets, same thing as before, but now when the admin runs this, they should be adding this little note. And then when it gets them, pulls them all from the database, this time it'll have information and it'll have the flag. Oops, I'm trying to, I guess I could just do all this in burp, but whatever. So then we go back in burp and then we go to our, okay, so we see it told us, hey, it added it, it was true, and here is our data. And then here's where we run into the other problem, which I'm sure if you were paying attention to, you would have been like, this idiot, this isn't going to work. It's all going to be encrypted. So we got the flag. It's in this. We just need to decrypt it. Well, how do we do that? And that's where the bad news comes back in, because now we have to deal with the same origin policy again. So remember, if like we wanted to, right, you might just be like, oh, let's just hit up the secret endpoint and we'll get their flag that way. Then we can just, or their secret key that way. Then we can just send it off to the decryption ourselves because we know what the flag is now. We can just get that. Well, that's not going to work because again, it's the same origin policy. Now we can make the admin visit their secret endpoint, but we can't get the key. Stupid, it's cached, so whatever. Here, put a repeater and get rid of this if not matched. So that's basically just saying like, hey, if it hasn't changed, you don't have to waste bandwidth giving me all that information back. So we can't we can have them visit their secret endpoint, but since it's cross-origin, their browser isn't going to let our script have access to this data to send back to us so that we can exfiltrate it. All right, so then we need to jump back into the code and figure out what's going on. Now, so there's a lot of paths you could go down, and you try to figure out, like, maybe there's some way with the, encryption. You can read what it's doing, try and figure out, like, is there a way to break the encryption, which probably isn't going to be the case because this is a web challenge, not a crypto challenge, and people tend to not like crypto, sadly, so I don't think they'd do that. But if we look at where in the WebSocket, how it's handling the stuff, how it's, like, let's go to where it's encrypting it. So, like, here was where it stuck the flag in the quote, and then it's encrypting the task title, task secret, task description, all that stuff into each one, and then sending it off. But if we look, that seems kind of weird, or at least it did to me, because, like, we have, like, when it adds to the database, there's this, right? The to-dos list is just the user ID and the data. There's not like a title or, anything like that. It's just all the data, 255 characters. And if we look at how it's doing it, it is sending it, that data it's sending it, inserting into the table, is a string that is formatted as JSON. So when it gets it out, it can just go somewhere. There's a JSON parse. Yeah, so see here, it's taking each task, which is this string that looks like JSON, and then parsing it, so it is JSON. And each entry into that to-do table has the title, the description, and the secret it was encrypted with. And there's a couple things to notice about this string. First off, to me, it seems weird. Like, why are we putting the secret in each entry when each user has a unique secret? And then even worse so, they're not putting the data in encrypted. They're getting it out decrypted, or not encrypted at all. They're getting it out in just normal plain text, and then they're encrypting it before it's sent with through the WebSocket. Well, just from a design standpoint, that's not very good, because let's say your secret key gets compromised or something happens and you need to change secret keys. Like, you don't want to encrypt all the old to-dos with that old secret that's been compromised. You would want to use the new secret. So you don't care what your secret was when this information was placed into the database. You want it encrypted with your current secret. And it makes even less sense because we see, where is it? Oh, yeah, it's getting the secret out of the database. So, like, this subsection of code has access to the current secret. So when they encrypt it, they could just do task title secret. Why are they using the task secret? It just doesn't make sense. And that's one of the kind of things you can use to key in on where in a challenge maybe something's going on, because if it doesn't make sense, now granted, these challenges are all arbitrary in a way where they kind of have to do things to make it nuts. There has to be something that's not right. Otherwise, it wouldn't be exploitable and it'd be impossible to get the flag. But it's also a good way, like, even if you're doing this in the real world, like, if you can come across something where it's like, that doesn't make sense. Like, it could just be maybe the developers are dumb and made it more complicated. But more often than not, really what it is like something got added later. They just sort of like patchwork in some code to make it work. And that, like, introduces a level of complexity. And that's where you're going to find a lot of vulnerabilities, is where, like, there's things aren't quite fitting together right. And they just sort of shoehorn stuff in, and they're going to have, like, missed something. The other thing to notice is, like, if we look at this, these backticks is what's called a string literal, string template literal, whatever it is. Anyway, it's a way to format strings where the data is, like, whatever data title is, gets stuck in here so that when the string is formatted. It's a way to like, I don't know. You can write this one string one time, and then as it iterates over, you know what I mean? It like, I don't know if I'm making it make sense. I'm probably just rambling like an idiot. And you probably already know what this is. But anyway, like this is injectable. Like we could make the description, we could give it a backslash, and then when it, so like whatever it's going to do, right? It's going to basically put data description in here. We could have it be, some description, I can't spell, backslash, and then make our own little foo bar. So we could introduce, we can basically escape out of that and introduce more key value pairs. Well, so one thing to think about then is, well, for a while, because I'm not super familiar with these template literals, was trying to figure out if I could just change it to get it to put it the secret in, like, the title or the description or something, which ultimately wouldn't have worked because that gets encrypted too. But you can change titles. Like if we look at, let me go back to the normal application. So if we give it a new title and we say we want the title to be like, this is a title, and then description is, I'm going to change the title. This is a new title, right? And then I don't break that off so that when it gets stuck in here, that quote gets stuck there. See, we can see that it changed the title from this is the title to this is a new title, right? So whenever you have like JSON like this, it's just going to take whatever the last occurrence was. Like if there's 2 title entries, it's going to take whatever the last title was and it's going to use that. So that got me thinking like, okay, clearly this is injectable. Clearly this doesn't make sense. So like this has to be the path forward to the solution to the flag, because I need a way to get the secret, because I need that secret to be able to decrypt. Unfortunately, this secret's at the end. So it's not like I can just make, like if I could inject a secret header here, right? Like I could have description be something, give it that unescaped parentheses, comma, make my own secret entry, give it a value that I want, but it's always going to take the last secret. But then that got me thinking like, oh, well, so this data here, it only stores 255 characters in the database. So what happens if you gave it, 1,000 characters? Does it throw an error? Does it just put in the first 255? Well, a little Googling, what it turns out, most databases just put in the first 255. So what we could do then is make it so that the description, or however we wanted to do it, how we do it in the description. Description is going to be a whole bunch of characters. Then we're going to escape it. We'll give it our own secret entry, and then we'll make that secret entry end at exactly 255 characters, so that when it inputs in the database, it gets inputted with our secret. And then when it comes back and is called up at here, it's going to encrypt it with that secret that we stuck in. So hopefully that made sense. So if we go back to our script that we've been writing. So this time, instead of just some description, let's just give it a whole bunch of nonsense and a key. So basically I figured out how long it needed it to be so that the string would end up being exactly 255 characters. And I'm just going to copy and paste it, what I got. If I can copy and paste correctly, I just have this off screen here. Actually, let me just copy the whole thing. That'll be easier. So we see here, we're doing the same thing, right? We're adding, I've got some title description. I've just got a whole bunch of A's, and then I put a double quote, a comma, a secret, and then I just picked whatever I wanted. I knew dead beef is 8 long, and the secret, if we look in, I don't have it open, but the crypto file, the secrets are 32. It's a 16 byte, so 32 hex digits. So I just repeated dead beef 4 times because I knew that would be 32 characters. Then we have to close off the secret. Then remember, because it's getting stuck in as a string that looks like JSON, so that when it's parsed, wherever it was here, when it's parsed, it turns it into a JSON, so then it can treat it like a dictionary, pull the secret out. So we need to remember to put in our closing and then this closing bracket here, and then I close off. So all of this right here is actually the description I'm sending. Oops. That's what I'm putting in as description. So now when we send this, the admin should add this in. That'll get inserted into the database. Then when it gets them, it's going to pull them out, going to encrypt it, but it's going to encrypt it with our dead beef key. So we know the key to that. So then we'll be able to take that, and then we can just send it to the decrypt endpoint ourselves, because all the decrypt does is it just takes the secret and the cipher structure, and so we can just input that ourselves. We don't have to have like the admin do it, which wouldn't help us anyway, because again, same origin policy, we can't get back what the admin accesses from a different origin. So if we go to, let's URL. Oh, what am I doing? Let's encode that. Go into our burp. And let's see if I did everything right. So now the admin should go to that page that we reported, run that our payload that's telling them to add that to-do task that we bypassed, that has the secret we know now, so that when it's pulled out of the database, it'll use that secret to encrypt, and then sending it to our webhook endpoint, so we've added 2 notes now. So we see there's 2, and we're going to want the longer one. We need the IV and the content, or no, we want the quote, but it's the one from the one that had the long description. So it should be this one, I believe. Hopefully, we'll find out. And then we're just going to go to the decrypt endpoint. And we're going to give it, oops, IV and content. And then our key was dead beef. 4 times. And there we got back. The wise man once said, the flag is, and there's the flag. That's not the actual flag, because I did all of this on my test instance. So if you want the flag, you can repeat all this on the actual thing, and then you'll have gotten credit for it.